Go ahead. I'd like to start off by thanking you for taking the time to attend this presentation today. My name is Lance Zurich, and I'm going to give you a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Each of these sets are designed for conducting what we would call a project-based class, where students will be required to design and build a series of original prototypes based upon their own research and activities. And each set includes standards-focused curriculum, created especially for Studica by noted educator and STEM expert, Tom White. Now, today we're going to start off where so many technology-focused presentations for education seem to start these days, and that's, of course, with talking about the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being the acronym which stands for science, technology, engineering, and mathematics, well, when somebody says this, what they're essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our grandparents or even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, IoT, and rapid advances in all aspects of technology. In short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. Now, this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage we enjoy, just such as the tablets and the smartphones that we all use daily, all of these things were created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Now, here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but also to be part of the next wave of advancements that we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, what we're going to do is we're going to move right along to the main topic, which is, of course, mechatronics. Mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, IoT, also known as the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, of course, and all skill sets that are highly prized in today's technology-focused job market. But just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether they're in the classroom or the homeschool environment, is finding ways of introducing this type of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas and to take a few tests, then promptly forget everything they know. No, to best help students to be successful and really to encourage them to consider pursuing further education in subject areas such as this, educators need to be able to present the material in a way that makes it relevant, which means, of course, answering the eternal student question, which is, why do we need to know this? And it also needs to be engaging in a way that holds students' attention much better than rote textbooks and lecture presentations, and something that has visible real-world applications where the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. These two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject, These sets were created to provide all of the materials in one place that educators would need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets comes with its own detailed day-by-day curriculum document, again created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program, as I touched upon before. And this means that solving the problems that arise in each unit requires that the students are to be actively involved in the research, the design, the trial and error experimentation and activity phases, and also in the building of actual working prototypes that will provide the required answers. And students won't be asked to do this alone. They're going to be asked to work in small groups or teams of 4 students each. This will help them to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And when we talk about things like soft skills, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, leadership. And finally, with the exception of some very affordable programming software, so affordable that it's free now, each set includes all of the physical building materials each group will need to enable to address all of the design projects presented throughout the course of the curriculum. Now, the curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or non-technology focused disciplines, to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow and providing a clear roadmap for student learning. Various supplemental materials are also included both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system that they will use to address each of the projects presented in the units. The units of the curriculum are designed as a series of projects once again, and each of these projects is presented to students in the form of an engaging real-world style scenario. And in this case, students must work together in small teams. Again, these are those teams of or groups of 4 students to create a solution. The project units each contain embedded academics. And at the end of each of these units, students will be required to make a formal presentation of the prototype that they've created to, again, address this particular unit's real-world style scenario, and also to explain the reasoning behind the way they constructed their prototype. There is a technical literacy task driven by each of these projects. As students work to address each project, they are going to acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Now, again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also to maintain detailed documentation during the entire process. Now, as I've touched upon a few times in this presentation, the curriculum that accompanies each of the Mechatronics program sets we're going to be looking at was created especially for Studica by a man named Tom White. You see Tom right here. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards that are currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. When students ask something like, why do we need to know this? It's usually because the subject matter that they're being presented with might come across as perhaps too abstract to ever be useful in their lives. Now, instead, when you use this kind of project-based approach, students get to see firsthand why these things are necessary to know and where they're useful. The concept of working in the small groups to solve the project problems being presented helps students to develop the high demand soft skills, once again, that employers look for, again, as much as they look for technical skills. They look for things like the ability to communicate. They look for analytical skills, quantitative skills. They look for flexibility, adaptability, and of course, problem-solving skills. In this project-based format, all of the subject matter is integrated. And by that, we mean the math is integrated with the reading and the writing and so on, which is really ideal for any kind of STEM education program. And also because of the manner in which students must approach each of the projects being put forth in the curriculum, again, with the research, the testing, and the group give and take to provide just a couple of examples. Because of this, it allows for much deeper exploration of problems than traditional teaching methods might normally allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, what you should see, or you should see variations in the types of prototypes and solutions that these different groups of students are coming up with. Now, this can be, of course, because of differences in creativity, differences in research, or the different approaches taken by each group. But in any case, students get to see firsthand that problems can have many different answers, and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and the knowledge that they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students at a time. This team approach, as stated before, helps promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And again, everything you need to conduct the programs, with the exception of the programming software, which I mentioned, which we'll talk about that after, is included inside of each box. Access to the free curriculum download is also included with the purchase of each set. And also included are all of the building materials which students will use in the creation of each of these projects and prototypes we've talked about. The materials that they're going to use come from the unique Fischer Technic building system, and among the components included in each set are 2 robotic controllers, such as you see on your screen now, and 2 power supplies. Of course, many of you may not be familiar with Fischer Technic, so please just allow me a minute to provide you with a little bit of background. Fischer Technic is a flexible and innovative construction system. Now, unlike other popular construction sets you may have encountered that are designed primarily to stack, the Fischer Technic system was created with more of an engineering mindset. The core building block in the Fischer Technic system is unique in that it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Many of the parts are designed to slide together and lock in place using a tongue and groove assembly method. And the system also includes a wide selection of very specific parts, variations on gears, variations on girders, sensors, and so much more, which will allow technical builders to address equally specific design needs. The Fischer Technic system was created back in the 1960s by German inventor Arthur Fischer, who you see on the screen now, and he's noted for countless innovations used in the construction and the automotive industries. Now, Mr. Fischer, at the time of his death in 2016, had amassed more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fischer Technic, Mr. Fischer was the inventor of synchronized flash photography, and this was back in 1949. And he was also the creator of the expanding nylon wall plug, which of course we all know about. You use it in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fischer Group, to this day employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing. And they're also known for providing services, consulting services, I should say, related to automated processes. Now, with all of this being said, let's begin looking at each of the two individual sets. And we're going to start off with the Studica Introduction to Mechatronics Program set. Or for those of you who like acronyms, you can refer to this as SIM. The set is designed to help provide a well-rounded introduction to the core concepts behind mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. Of course, you see a copy of that on the screen now. The curriculum contains enough activity material to fill approximately 45 academic hours. Because of this, we recommend this program set for insertion into regular related class activities. It could also be used as a short class unto itself. It could be used for an after-school program, or of course for homeschool use. The curriculum created for this set is standards focused. And again, using the academic standards most widely recognized in the US-based education system today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again for addressing the same grade levels in a homeschool environment. The set itself contains a collection of over 700 Fischer Technic building components, and again, this includes everything from gears, wheels, axles, blocks, sensors, and so much more, as well as, again, 2 robotic controllers and 2 power supplies. The curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, the conversion and storage of energy, and an introduction to control systems. Now, there are also activities included to address the following topic areas that will come up during the course of the curriculum. There are sections on sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using the software and robotic controllers, working with sensors such as the digital switch and the digital phototransistor, learning about open loop and closed loop programming, working with digital branching, working with analog sensors such as the photocell LDR, working with analog branching, exploring more sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what is covered in the second set. This is the Studica Teaching Applications of Mechatronics Program. In this case, if you want to use the acronym, you can call it STAMP. This set is designed for those educators and those homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set comes with access to a free downloadable 400+ page curriculum document entitled Mechatronic Applications, again by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. Essentially, 4 times the amount of academic hours is covered by the previous set. Now, as such, this set can be seen as a more expansive version of the material touched on in the first set, and is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes per day for 5 days a week, or the equivalent, each week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and is designed for use in middle school, high school, or again for addressing similar grade levels in a homeschool environment. The materials in this set consist of a selection of over 1,200 Fischer Technic building components, and once again, this will include a wide array of gears, sensors, axles, blocks, and so many more other, very unique pieces, as well as 2 robotic controllers and 2 power supplies. Again, software is required for this set as it is for both, and we'll tell you about getting that at the end. Now, there are twice as many project units included in the Studica Teaching Applications of Mechatronics Program set as there were with the previously discussed set. And this includes units on areas such as, again, sketching and documentation, simple machines, mechanical systems, basic electricity, and also project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided to tutorial sections and activity materials for students to utilize, and these include sections on the following areas: sketching, linkage diagrams, schematics, Ohm's law on power, flow charts, using the programming software and the robotic controllers, open loop programming, working with sensors such as the digital switch and the digital phototransistor, working with closed loop programming, working with digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. Now that we've had a look at how each set differs and the specific subject matter covered by each of these sets, let's now look at exactly how the curriculum itself is structured. Both versions of the curriculum share the same format when it comes to the structure of each project unit. And as we already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. In each case, the curriculum is also designed to be what we would call turnkey. What we mean by this is that each unit is designed to clearly spell out everything being addressed, and again, to provide tutorials and other information as the topics arise. Now, this was done specifically to enable teachers from all types of backgrounds, and this includes those teachers who may come from a non-science or non-tech focused background. If this was again designed to enable teachers to quickly become comfortable with delivering the material by reviewing each section before they present it in class. Each unit presented in the curriculum for each of these sets includes the following sections: an introduction, a description of the purpose of the project, discussion of the concepts, an outline of what will be covered, a listing of all the standards that will be addressed. Assessment rubrics are provided. The essential question to the students to solve is put forth. The student scenario, once again, that real world style scenario I've talked about several times. There's a daily plan. Vocabulary is part of it. And there are also various resource materials. So with that all said, let's take a look at each of these sections a little bit closer. The introduction or the purpose of the project. So each unit starts with an introductory section and again, the purpose of the project that's going to be looked at. Now, just as you would likely gather, this is the section that provides a brief description at the top of the topic that's going to be explored in the coming days and in the activities. And it's also seeking to clearly spell out to the students why they're learning this material and why it's important for them to know this. The next section focuses on the main concepts to be addressed in the unit at hand. And these can be thought of as the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, not only today as they do this project, but also to draw upon as they move forward in STEM fields of study. And of course, if they chose to pursue it further in STEM related careers. Following that, we encounter the outline. In this section, we drill down more specifically to what will be addressed in the unit. Now, as the example shown on the screen right now is taken from the unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, for example, flow charts or word problems. We get into things like program characteristics, as again, things like open or closed loop programming, branching, would it be digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards which will be addressed in the unit at hand. As you will see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include rubrics both for the specific project being covered and also general rubrics for literacy tests. Next up, we encounter the essential question, and this can be thought of as the big picture question that's going to be focused on in each of the smaller individual activities, and of course, all of the aspects of the larger project which students are going to be asked to complete and work on in the section. When we get to the student scenario, this is where specifics of the project to be addressed are finally all spelled out. Now, this is again presented in the context of a real world style scenario where students are presented with a problem that needs to be solved and the creation of some sort of device, machine, or mechanism. So as I mentioned before, students are not going to do this alone. They must work together in small teams, again, of 4 students per team, ideally, and they have to work together in these teams to craft the answer to the challenge they're being presented with. Now, solving this problem will require each team of students to design a unique and original answer, which once again, will usually be in the form of a working prototype, along with whatever programming may be required to help this thing function. Now, just to provide an example, if you look closely at the student scenario that I'm showing on the screen right now, you'll see that the project in this unit has each group of students take on the role of a design team employed by a firm that manufactures garage door openers. In this particular case, students are being required to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out. In this case, it includes things like the use of limit switches, meeting certain safety codes that require a method for sensing if anything is in the way of a closing door, and also in the incorporation of an automatic light. Again, each team of students will be tasked with creating both a unique and an original prototype, and in this case, that would be the garage door operating system, the opening system, and they also have to create whatever programming is needed to control the prototype. Now, as students move through the challenge being put forth in this scenario, each of these teams will be required to document the entire process in both a design notebook and digital engineering journal. And this means they have to notate all the research, all the trial and error experiments. They have to keep copies of all the design sketches and revisions and so on. Now, at the end of each of these project units, again, each team of students will be required to make a formal presentation in front of the class, during which they will be asked to demonstrate their prototype and the programming used in action, much as they would be required to do for an actual employer or client in the real world. The next section we encounter in the curriculum is the daily plan, and this is the section that clearly spells out both for students and teachers what's going to be expected of the students, how the teacher will conduct the day's classroom activities, and what specific subject matter is going to be covered. Now, some days may involve things like discussions. Other days may be more focused on research or perhaps on building small projects that will help provide kernels and building blocks that students are going to draw on to complete the larger projects that we've talked about in the student scenario. Now, in short, what you can really think of the daily plan as is kind of a roadmap designed to keep everyone on the same pathway. Now, you'll see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what's going to be required in the design notebook that the students are being asked to keep, or how to use the control software they're going to be working with, or working with the controller, or with flowcharts, or what have you. That as each of these types of topics come up, there are links to sections that provide further instructions and information on that particular area. Now, at the completion of each unit, after the last day of the daily plan, there's a section containing vocabulary. These are always going to be important words and terminology introduced during the project unit. And there's also going to be a selection of useful resource materials. Now, these resources can contain a mix of different types of material, everything from carefully vetted websites and video links to things like PDF documents or even PowerPoints and so on. Now, besides the project units, each of the curriculum documents also includes a special tutorial section designed to educate both students and teachers on how to use the unique Fischer Technic building system. Now, this includes information on how the parts fit together using the pin and groove assembly method I mentioned before, how to identify the different types of parts from the various types of girders and blocks, the different types of axles, gears, rivets, and so much more. And students also get to build a very basic sample model just to help them familiarize themselves with using the system before they move on to the projects that are presented in each of these units. And again, as learning about and maintaining proper documentation is one of the key areas stressed in the course of the curriculum, there is a section which details just what defines each type of documentation listed on the screen now and what sort of documentation is required for each of these. And as the process of conducting these types of more open project-based class activities may be new to some teachers, there's also a section that discusses specifically project-based STEM education and its benefits. And that completes our overview of these two sets. With that in mind, let's quickly review the contents and purpose of each set, but this time with some pricing. First, we have the Studica Introduction to Mechatronics Program set, which again is designed as a standards-focused project-based introduction to the core concepts of mechatronics. Again, it includes the highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the building materials included in this set, will provide teachers with enough academic activity material to fill approximately 45 classroom hours. And it's again designed for those educators who wish to offer a shorter class on this material, who intend to use it for after-school programs, or of course, those who might wish to use it for homeschool use. The teaching materials designed for use again in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in this set include a selection of over 700 components, again, including the blocks, gears, sensors, and much more, all coming from the Fischer Technic building system, along with 2 robotic control units and the power supplies. These materials will once again be used to construct the various mechanical prototypes addressed in each project unit of the curriculum. Software is again required, and we'll talk about that in just a second. Again, each set is designed to be used by teams of 4 students at a time, with pricing starting at just $699 for a single set. Of course, discount classroom pricing for groups of 20 students and up is available by quote upon request. Next, we'll look at the STEM Teaching Applications of Mechatronics Program set. This is again designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics, which again is based around a highly detailed 401-page curriculum document entitled Mechatronics Applications, written by noted STEM expert Tom White. When used in conjunction with the building materials included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. And this is designed specifically for those teachers and those homeschoolers who are able to dedicate a daily class period of 50 minutes per day for 5 days a week, or the equivalent, to this subject for a full academic year. The set again is designed for use in middle schools, high schools, and also homeschools at the same subject or at the same grade level, and those who want to address STEM and mechatronics. Each box contains an assortment of over 1,200 components from the Fischer Technic building system, and again, this includes an assortment of blocks, gears, sensors, girders, axles, and many other types of pieces, as well as 2 robotic control units and 2 power supplies. And again, the required software has to be obtained separately. Again, each set is designed for use by teams of 4 students at a time, with pricing for a single set starting at only $799 for a single set. But classroom pricing for 20 students or more is available by quote upon request. And as I mentioned that the software is required, let me address that as well. And it's going to kind of void what you see up here on the screen. The software used is the Fischer Technic Robo Pro graphic programming software. It is again for Windows 7, 8, and 10 as it shows on the screen. It's not used for Chromebooks. So if you're using Chromebooks, unfortunately, this would be an issue. Where we will ignore is, if you notice, I have some part numbers up here. I have a single user license up there for $36 per license. There's also an unlimited single site school license listed at $120 per license. Because of changes with Fischer Technic, they are now offering this software free of charge as long as you register on their website. So you can simply go to their website. You'll be able to register and download a copy of this to use absolutely free. So on that note, if there are any questions, I would ask that you use the Zoom chat window or the question window to ask any of those things you might have that might come up. Whether you have any questions about this specific set, because of course I'm mentioning Fischer Technic, as you know, we are the US distributor for Fischer Technic. If you have any questions about Fischer Technic products, you can also ask those now as well. I'll give you a minute before moving it along, going once, going twice. Well, if you don't have any questions at the moment, I will give you some other avenues for that. But right now, to take the next step, if you'd like to request a quote, if you would like to speak with your dedicated educational representative, depending on what state you're in, you can call us. Our number here in the US is 888-561-752. And of course, that's toll free. You can ask for any of your sales reps when our receptionist picks up. If you want general information, pricing, what have you on this or other Fischer Technic related items, you can simply email us at info@Studica, Studica.com. Or if you have questions for me specifically about anything I discussed today, anything you wish I would have discussed, any aspect of Fischer Technic, the project-based learning programs, what have you, you can just email me directly as well. Just mention that you attended the webinar and you have some questions. My email, of course, as you see on the screen, is lance.zurek. That's lance.zurek@Studica, Studica.com. So on that note, I'd like to thank you all very much for attending today. And again, we look forward to hearing from you. Have a great day. Take care.